Assalamu alaikum students. With regard to this topic, introduction to graphs, we try talking about these graphs. We also discussed the various types of graphs, and we also talked about coordinates, in which we try locating a given point plan. Okay, today we are going to take some examples and learn how to draw graphs using a proper scale, right? So let's take some examples in order to point out how to draw graphs if data is given, right? Okay, so we'll try to draw graphs using a given data with suitable scales on the axis, right? Let's take some examples. Okay, this is a given data, cost of apples. Okay, so number of apples and their cost in rupees. One apple costs rupees 5, 2 apples cost rupees 10, 3 apples cost 15, 4 apples cost 20 rupees, and 5 apples cost 25 rupees. Okay, this is a given data, out of which we have to draw a graph using a proper scale on the axis. First, what we have to do, if we intend to draw the graph out of this data, what we have to do, first we have to draw the two coordinates. Say for example, this is x coordinate. Say for example, this is x coordinate, and this is y coordinate. Okay, so say for example, this is y coordinate, this is x coordinate, this is y coordinate. Okay, this is called as origin, right? Now we have to use the suitable scales on x and y axis. Say for example, see, okay, this is x coordinate, right? So we will use the scale there. Okay, so we'll divide it x-axis into equal parts. Each part is equal to 2 centimeter. For example, this is 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter, 10 centimeter, 12 centimeter, 14 centimeter, then 16 centimeter, then 18 centimeter. Okay, here also 2 centimeters. Okay, 16, 14, 12, 10, 8, 6, 4, 2, and this is 0, right? So for example, on this axis this axis will use it for number of apples, right? So number of apples, for example, this is 1 apple, 2 centimeter is equal to 1 apple. Then 4 centimeters, 2 to 4 centimeters, 2 apples, 3 apples, 4 apples, 5 apples, right? Then here 2 centimeter is equal to rupees 5. So this is cost in rupees, cost in rupees, right? So this is 5 rupees, 10 rupees. Okay, so here it will be 0 apple, it's 1 apple, 2 apples, and here it will be 0 rupees. Then somewhere between it will be 2.5 rupees. Okay, here it is 5, somewhere between 5 and 10 it will be 7.5 rupees. 5 plus 2.5, that is 7.5 rupees. Then 10. Okay, then 15, then 20, then 25, then 30, so on and so forth. Okay, so we have data up to this 25. Okay, we'll stop right here, 25. Okay, then what we have to do, okay, one number of apples, 1 apple costs us rupees 5. For example, 1 apple costs rupee 5. So what we have to do, okay, so on the x-axis we have to move towards right by 1 unit, so that means here, and on the x-axis that means we have to move upwards by again 1 unit, so up to 5, right, up to 5. So here is a 5, that means here some point will be, okay, somewhere here, right. Okay, then in this case we have to move by 2 units, so here, and upwards by 10 units, so that means this is 5, here it will be 5, and then here it will be 10, right. So you can check it with the help of a scale. Say for example this and this, with this, so somewhere here, this, then 315, so this is 15 and this is 3, so somewhere here, right. Then 420, 420, 420. So this can be better drawn on the graph sheet, okay. Then 525, 525. Okay, now try joining these points. So you can see that this line will pass through the origin, right, and so this line will pass through the origin and we get a straight line. So this means that, okay, this means that as the number of apples increase, the cost increases, right. This is so that means the cost of apples, this is a dependent variable, okay, it depends upon the number of apples. As the number of apples increase, okay, so the cost also increases, right. And in such a graph in which we get a straight line, that's called as a linear graph. That's called as linear graph, right. But it's not necessary in a linear graph. Linear graph always passes to the origin. It's not necessary. Linear graph cannot always pass to the origin, okay. So the point is the linear graph is one in which we get a straight line, whether it passes through the origin or not, okay. So that's called as linear graph, right. Okay, now okay, there's another example. So that is distance traveled by a car. Distance traveled by a car. Okay, at 6 a.m. the car has covered the distance of 40 kilometers. Okay, this is the distance in kilometers. Okay, and this data shows the time intervals. At 6 a.m. the distance covered by this car was 40 kilometers. At 7 a.m. it covered the distance of 80 kilometers, and at 8 a.m. the car covers the distance of 120 kilometers, and at 9 a.m. it covers the distance of 160 kilometers. So we can say that from 6 a.m. to 9 a.m. it covered the total distance of 160 kilometers. So in the total of 4 hours, the car covered the distance of 160 kilometers. Okay, this is what the data reveals, right? Okay, let's try to draw this data, okay, in the form of a graph. Okay, say for example this is x-axis and this is y-axis. On x-axis we will show the time in hours. Time in hours. Time in hours. Time in hours. On y-axis, we will show distance covered. Distance covered in kilometers. Right. Okay. On x-axis, we will use the scale. Okay, 1 unit on this y-axis. Okay. So, for example, this is the scale. We will divide it into equal parts. So, for example, 5 centimeter. At 5 centimeters, 6 a.m. At 10 centimeters, 7. At 15 centimeters, it is 8 a.m. At 20 centimeters, it will be 9. Then at 25 centimeters, it will be 10 a.m. Right. So this is 6 a.m., 7 a.m., 8 a.m., 9 a.m. Okay, so what we have to do is to divide this x-axis into equal parts, right? Okay, so each part is equal to 5 centimeter. Okay, so then on this here, we'll again use the same scale. Say, for example, 5 centimeter is equal to 40 kilometers. Okay, 5 centimeter is equal to 40 kilometers. Another 5, so that means 10 kilometers. The 10 centimeter is equal to 80. So then another 5, that will be 15. Then 20. Okay, then 25. Right. Okay, so here it will be 40 kilometers. Here it will be 0 kilometers. And from here to here it will be 40 kilometers. From here to here it will be 80 kilometers, right? Okay, so it will be 80 kilometers here. It will be 40, 80, then again 40 kilometers. The scale should be, that will be, each unit is equal to 40 kilometers. Should be equal to 40 kilometers. And here it will be 120, and then it will be 160 kilometers here, right? So each unit is equal to 40 kilometers. 40 kilometer here, 40 kilometer here, 40 kilometer, 40 kilometer. Okay, so here it is. Here it is 1 hour. From 6 a.m. it's again 1 hour. From 7 a.m. to 8 a.m. then it's again 1 hour. Here 1 hour, right? Then now we have to get the points on this graph, right? 6 a.m. corresponds to 40 kilometers. So 6 a.m. corresponds to 40 kilometers. So here it will be 1 point. 7 a.m. corresponds to 80 kilometers. 7 a.m. corresponds to 80 kilometers. So this is 80 kilometers. Okay, so the point will be somewhere here. Okay, then 8, 120, 120 to be somewhere here. Okay, then 160 kilometers. For that we have to wipe this off. Okay, then for 9 a.m. it will be point will be 9 a.m. somewhere here. Okay, let's try joining these dots. So this graph also passes through the origin, right? Okay, so the position of this point has so it will be somewhere, for example, here. Then it will be yes. Okay, so this is the time and distance graph. Okay, this is again a linear graph. Right. Okay, now say for example there's a question. If anybody asks you the question, how much distance did the car cover during the period 7:30 a.m. to 8 a.m. Okay, means between this time period, how much the distance did the car cover? Okay, so first we have to locate this. Where will be this time period 7? Time period starts. Why does this time period starts. So 7:30 a.m. So it is 7 a.m. here, it's 8 a.m. So somewhere between the 7 and 8 a.m. Okay, somewhere here it will be 7:30 a.m. to 8 a.m. So we have to find the distance covered by the core between this time period. So the time period is here 7:30 a.m. Okay, this is 7 a.m. This is 8 a.m. So it will be here 7:30 a.m. So this is the time period, and we have to find out the distance covered by the core, right? So we will try drawing the lines. Okay, so for example this, then 8, this. Try joining these lines to the y-axis, this and this. For example, so that means the distance covered by the core is this much between this time period. Okay, so this line corresponds to the point somewhere between 80 and 20, so it will be 100 here. And the distance, this much distance, corresponds to the distance between 100 kilometers to 120 kilometers. So the difference is 20 kilometers. So the distance covered by the core between this time period is 20 kilometers. Right? Okay. There is another question. What was the time when the core had covered a distance of 100 kilometers since it starts? So the core starts from here. Okay, starts here. Okay, so we have to find the distance of 100 kilometers. Okay, so the time at which the core completed the 100 kilometers of a distance. So 100 kilometers of a distance is over here. Okay, the time at that point of, okay, the time was 7:30 a.m. The answer is 7:30 a.m. Okay. At 7:30 a.m. the core covered the total of 100 kilometers of distance, right? Okay, so that means what we have to do, we have to first locate wire on the x-axis will be 7 a.m. and then we have to correspond that point with the distance the y-axis, right? So it will be 7:30 a.m. right? Okay, so this is how, okay, we can draw the graphs, and we also come to know what are linear graphs. Okay, so this is all about these graphs, right? Okay, in the next video lecture we'll take another important topic about the elementary maths, right? Till then, Khuda.